All right, you are welcome again. Today, let's consider arc length using table. How we can use table to solve definite integral. You get it? How to use table to solve definite integral. Now, we want to use table to find arc length. Okay? Now, let's take a look at this question. This question says, find the area of the following curves. Find the area length of the following curves. Number 1, y is equal to x squared between x equal to 0 to x equal to 1. Then number 2, y is equal to x cubed plus x between x equal to 0 to x equal to 3. You get it right? Yes. We are asked to find the area length of the following curves. So we are going to use table to solve this. But before we use table, we are going to solve to the point where it is difficult for us to continue. So from there, we can introduce another method. Okay? Now, we know that the area length of an arc, the formula is given as the integral from a to b square root of 1 plus f prime of x squared dx. Okay? Yes. Now, in the first one, we have our function of the curve y is equal to x squared. Now, we can take this to be our f of x. Okay? So we say that our f of x is equal to x squared. Now, let's go further to find f prime of x. That is, we find the derivative of this function x squared, okay? So f prime of x is going to give us 2x. That is, when we differentiate x squared, it's going to give us 2x. Is that true? Yes. Now, let's go further again to find f prime of x squared. We have gotten f prime of x, right? Good. Let's go further and find f prime of x squared. So when we say f prime of x squared is equal to whatever you have here, which is 2x, we take the square of it. That means going to say 2x squared. Now, if we distribute this squared, this exponent 2, into the content in the bracket, when we distribute it, it's going to give us 2 squared times x squared. Now, when you say 2 squared, it's going to give you 4. And then we have x squared. So, we have that f prime of x squared is equal to 4x squared. Is that true? Yes. You still remember that the formula for area length of an arc is given as the integral from a to b square root of 1 plus f prime of x squared dx. And we have solved, we've gotten f prime of x squared. Is that true? Yes. Let's fix it in this our function. So we're going to say that the area length is going to give us the integral. The boundary we have is from 0 to 1. Then square root of 1 plus our f prime of x squared, we have 4x squared dx. You get it right? Yes. Now, when you look at this very well, we have integral from 0 to 1, square root of 1 plus 4x squared dx. If you try to use a simple substitution, it will not be possible to solve this. So when we get to this level, or whenever you are solving and you get to this level, we have two solutions. We have two possible solutions. Number 1 is to use calculator, scientific calculator, to solve this directly, or to use table. Okay? Yes. Okay, if we are to use scientific calculator, it's going to give us approximately 1.48. So the integral from 0 to 1, square root of 1 plus 4x squared dx, using calculator, is going to give us approximately 1.48. So we can say that 1.48 is the area length of the curve y is equal to x squared. You get it, right? Good. Now, we are going to use table to solve this and see whether we're going to get the same thing that calculator gives us. Okay, but before we do that, let's take number 2. Number 2 says y is equal to x cubed plus x between x equal to 0 to x equal to 3. So we say that this is our y, right? We can say that this y is the same as f of x is equal to x cubed plus x. All right, good. Let's go and find f prime of x. So when we say f prime of x, that means we're going to differentiate this function. So when we differentiate x cubed, it's going to give us 3x squared. And when we differentiate x, it's going to give us 1. So f prime of x is equal to 3x squared plus 1. You get it, right? Now let's also go further and find f prime of x squared. So that means we're going to take the square of both sides. Okay, that means we say f prime of x squared is equal to 3x squared plus 1 in bracket squared. You get it, right? Yes. And then you still recall that our formula for arc length is the integral from a to b square root of 1 plus f prime of x squared dx. Let's fix it in. We're going to say that the area length of the arc y is equal to x cubed plus x between the interval 0 to 3. It's going to give us the integral from 0 to 3 square root of 1 plus our f prime of x squared. Now we have 3x squared plus 1 in bracket squared dx. You get it, right? Yes. From this place, it is also difficult for us to continue this integration. So we have only 2 possible solutions. Number 1 is to use calculator and solve this directly, and number 2 is to use table. Okay, if I are to use calculator and say the integral from 0 to 3 square root of 1 plus 3x squared plus 1 squared dx is going to give us approximately 30.3665. It's going to give us approximately 30.3665. Okay, now what if we decide not to use calculator and we want to solve this by ourselves using table? How can we do that? Now let's go. Let's take the first one. Okay, let's take the first one. Now I want to show you the formula we can use when you want to use table. Now take a look at this. We have h all over 2 open bracket f of a plus f of b plus 2 open bracket summation of rem close the bracket. So this is what you will use to solve this integration using table. That is when you want to use table. You make use of this formula, okay, without using calculator. But the question is, what is h? We see that h is going to give us a plus b all over n. A plus b all over n. So what is n? N can be any number. You can decide to say that your n is 10, or your n is 20, or n is 15, or your n is 5. Okay, good. Now let's go. We say that to find area length of an arc, we are to say integral from a to b square root of 1 plus f prime of x squared dx. Is that true? Yes. And when we solved the first one, we saw that we have integral from 0 to 1 square root of 1 plus 4x squared dx. From this place, we have our a to be 0, that is the interval, the lower bound, and then we have our b, the upper bound, to be 1, and we say let n be 10. We decide to choose 10 to be equal to n. Okay, good. So here we said h is equal to a plus b all over n, right? Good. Our a is 0 and our b is 1, so we say 0 plus 1 all over n. N is 10, so we say 0 plus 1 all over 10 is equal to 1 all over 10. So 1 all over 10 is equal to 0.10. Is that true? Yes. Now I want you to form a table of 4 columns. A table of 4 columns, and then the rows should give us 13 rows. 13 rows and 4 columns. Okay, now the first row we are going to write x, and then you give a space and write square root of 1 plus 4x squared. That is what you want to integrate. You get it right? What you want to integrate, which is square root of 1 plus 4x squared. Now you give a space and write F and L, that is first and the last. The first and the last. And then we give a space again and write rem, that is remainder. Okay, you write remainder. Okay, good. Now we have choosing n to be what? 10. The first number under x, we're going to start with the lower boundary, which is 0. So here we're going to have that our x is going to give us 0.000. 0.000. Okay, good. Under 0.000, we're going to have 0.100. After that, we're going to have 0.200, 0.300, 0.400, 0.500 until we get to 1. So when we get to 0.900, then we get 1.00. Is that true? Yes. So if we have gotten these values we called x, we have it to be from 0 to 1, and then in between we have 10 values. Okay, so here we have 0.00. In the function that we have square root of 1 plus 4x squared. In place of x, we can replace it with these values under x. You get it right? Good. The first one we have 0.00. So in place of x, can we replace it? That means we are going to say square root of 1 plus 4 open bracket 0 raised to power 2. When you say 0 raised to power 2 is what? 0. 0 times 4 is 0. 1 plus 0 is 1. So we say square root of 1, which is equal to 1.00. Is that true? Yes. Now, in the place of F and L, that is first and last. So what is the first value you just gotten now? Is 1.00. So we write it under this place. So in rem, we have no remainder. Okay, good. That is, this remainder is talking about after first and last. Which ones are remaining? The remainder here is talking about after first and the last. What are remaining? So the ones that are remaining after first and last is the ones you write under the column of remainder. Is that clear? Yes. Now let's go. Let's go again. We have 0.100. In the place of x, in square root of 1 plus 4x squared, in place of x, let's replace it with 0.1. When you punch it, it's going to give you 1.0198 approximately. Okay, good. Remainder, we'll write it in remain, right? In the remainder side, right? Okay. Now let's go again. 0.200. In the place of x, in square root of 1 plus 4x squared, let's replace x with 0.2. So when we do so, we're going to have 1.0770. They will also write same in the remainder side. When we impute 0.3 in the function in place of x, it's going to give us 1.1662. We also write it in remainder side. We go again, 0.4. It's going to give us 1.2806. We also write same in remainder side. We go again to 0.500. We replace it in place of x in square root of 1 plus 4x squared. It's going to give us 1.4142. We also write it in the remainder side. We go again to 0.6. It's going to give us 1.5620. We also write it in the remainder side. Then we have 0.7. When you replace it, it's going to give us 1.7205. We also write it in the remainder side. We go again to 0.8. It's going to give us 1.8868. We also write it in the remainder side. And then we'll go again to 0.9. It's going to give us 2.0591. We also write it in the remainder side. And then we have 1.00. When we replace it, it's going to give us 2.2360. Now we write it under first and the last. So we said the first and the last is the given value for the interval A and B. So when you find A, write it in the place of F and L, that is first and the last. And then when you find the value of B, you also write it in the column of first and last. So the rest after the first and the last should be written under the column for remainder. That is the values that are remaining after the first and the last. Okay, good. So we have done this. Okay, now let's also do something again. We're going to say summation or the total. So the total of the first and the last. So when we say 1.00 plus 2.2360, when we add this together, it's going to give us 3.2360. All right, good. Now let's also find the summation or the total of the remainder. That means going to say 1.0198 plus 1.0770 plus 1.1662 plus 1.2806 plus 1.4142 plus 1.5620 plus 1.7205 plus 1.8868 plus 2.0591. So when we add all this together, it's going to give us 13.1862. You get it right? When we add the remainders, it's going to give us 13.1862. You get it right? Good. Here we're going to say that the area length of an arc, which gives us the integral from a to b square root of 1 plus f prime of x squared dx, is the same as saying h all over 2 open bracket f of a plus f of b plus 2 open bracket summation of the remainders close bracket. Okay, now let's go. Let's fix it in the values that we obtain. Okay, so first of all, we say that we have the integral from 0 to 1 square root of 1 plus 4x squared dx. Okay, now the value of this is what we are actually solving for. Okay, good. Now let's go. In our formula we have h, right, and we have calculated h to be 0 plus 1 all over 10, which is a plus b all over n. All right, so when you say 0 plus 1 is going to give us 1 all over 10, we have 1 all over 10, which is 0.10. all right, so here we have h all over 2 is going to give us 0.10 all over 2 open bracket. In the place of f of a, we have 1.00, which is the same as saying 1. all right, good. And then in the place of f of b, we have 2.2360. Then we say plus, we have 2 open bracket summation of remainders. So the summation that we have is 13.1862. You get it right? Close the bracket. Good. Now from this place, when you say 0.10 divided by 2, it's going to give us 0.05. Okay, good. Now let's go again. When we say 1 plus 2.2360, it's going to give us 3.2360. Okay, good. When you use these 2 to open the bracket, that is going to say 2 times 13.1862 is going to give us 26.3724. You get it right? Good. Now let's go again. Here we have 0.05 open bracket 3.2360 plus 26.3724. You get it right? Yes. So when we add these numbers in the bracket, that is 3.2360 plus 26.3724. When we add this together, it's going to give us 29.6084. It's going to give us 29.6084. So we have 0.05 outside the bracket. So 0.05 multiplied by 29.6084 is going to give us 1.48 approximately. It's going to give us 1.48 approximately. So we discovered that when we used calculator, it gives us approximately 1.48, and then we try using table, we got the same value, 1.48 approximately. You get it right? So therefore, this is how to solve arc length using table. I want you to try the same thing in the second example. Let's see whether you're going to get the same thing. All right? Yes. Thank you very much for watching. Please, if you have not subscribed, please subscribe, like and share our videos. Keep watching and stay blessed.